5G, and wireless body area networks. 5G wireless is the next step in the evolution of mobile communications, with the aim being to provide connectivity for any kind of device and any kind of application. Wireless body area networks, W-bands, constitute just one of the components of connected healthcare, utilizing small, intelligent physiological sensors, either on or implanted in the human body. This contribution examines the 5G technologies that will make a significant contribution to providing secure, healthcare-oriented W-bands with improved energy efficiency, interference mitigation, and wireless power transfer capability. The key words here are W-bands, interference mitigation, energy efficiency, millimeter wavelength, network coding, and security. 5th generation, 5G, wireless access is the next step in the evolution of mobile communications, with goals that include providing connectivity for any kind of device, an order of magnitude increase in data rate, higher energy efficiency, as well as compatibility with previous technologies. The ultimate aim being successful management of future mobile device requirements. To be able to achieve these goals, a variety of 5G enabling technologies are being developed. These include extending wireless communication to higher frequency bands, the development of advanced multi-antenna systems, and the use of wireless power transmission. In addition, to be able to evolve beyond 4G, intelligence, communication capabilities, and processing power will need to be diffused across networks and mobile devices, empowering even the smallest of connected devices. The European 5G public-private partnership have, for example, funded projects in areas ranging from physical layer to overall architecture, network management, and software networks. To achieve all the above, most likely new paradigms and enablers, such as software-defined networking and network function virtualization, need to be supported. In such ultra-flexible environment, it is necessary to consider new solutions, such as the separation of user and control planes, and possibly redefinition of the boundaries between network domains, for example, radio access network and core network. The recent advances made towards totally connected healthcare due to advances in wireless and electronics technology promises to increase not only the quality of healthcare, but also patient accessibility, while achieving all this at a lower cost per patient. Wireless body area networks, W-bands, have great potential for continuous patient monitoring in ambulatory settings, as well as the early detection of abnormal conditions and supervised rehabilitation. A typical wireless body area network, W-band, consists of a number of inexpensive, lightweight, and miniature sensor platforms, each featuring one or more physiological sensors, such as ECG, blood pressure, EEG, and blood glucose sensors. The sensors could be located on the body as intelligent patches, integrated into clothing, or implanted in the body. The trend is towards integrating implanted miniature devices into W-bands. For example, deep brain stimulation for the control of Parkinson's disease is becoming viable. W-bands are generally categorized by a 3-tier architecture composed of number 1, body-worn or implanted sensors, number 2, a hospital information system for storage and management of health data, and number 3, a mobile device that acts as a personal gateway between 1 and 2. The continuing advances in W-bands are driven by developments in wireless communications, as well as pervasive and wearable computing. This contribution provides a brief overview of 5G enabling technologies and the ways in which they can make a significant contribution towards realizing the full potential of healthcare-oriented W-bands with regards to energy efficiency, interference mitigation, wireless power transfer, and security. So if we look at the image, you have your W-band, and then you have the short-range communication between the W-band and your local receiver. And then you have the long-range communication between your local receiver and the long-range receiver, which would be your 2G, 3G, 4G, and 5G. Now we're going to go over here to gao.gov and we're going to read 5G wireless, capabilities and challenges for an evolving network. And once again, this is on an official government website. This is not a conspiracy theory. They tell you everything right here. 5th generation 5G wireless promises not just to increase speeds, but to enable new applications like automated cars and smart factories. We reviewed US 5G development. It's still early, with efforts focusing on increasing speed and connecting more devices. Technologies that enable 5G's full potential are expected within the next decade. We also highlight key challenges to 5G and present policy options to address them. For example, 5G is expected to greatly increase data transmission, which would require more radio frequency spectrum, a scarce resource. To help, policymakers could promote research into more efficient use of radio spectrum. We're going to click right here to open the full PDF file. What GAO found. 5th generation 5G wireless networks promise to provide significantly greater speeds and higher capacity to accommodate more devices. In addition, 5G networks are expected to be more flexible, reliable, and secure than existing cellular networks. The figure compares 4G and 5G performance goals along 3 of several performance measures. Now if we scroll down, all the way to this image. Applications of 5G. Smart logistics use data to optimize traffic and logistics management systems to improve the flow of vehicles and goods. Smart agriculture is the use of Internet of Things and other technologies to more effectively produce food, such as through improving crop yields and saving natural resources. If you're interested in 5G wireless and all of its technologies, you should read this entire PDF file. I will leave the link up in the description. But for now, we're going to go over to Springer Link, and we're going to read the digital twin in human activities, the personal digital twin. With the 5G era evolving continuously towards maturity, ICDT deep convergence is accelerating, and so is the transformation of our society. Simultaneously, advanced exploration of the 6G vision, where a new era of digital twins, pervasive connectivity with ubiquitous intelligence, is emerging. We expect the physical, biological, and cyber worlds to be fused together via the new generation of intelligent connectivity. In such an era, everyone may have his or her own personal digital twin in the cyber world. Such a personal digital twin may include the person's external appearance, as well as its internal organs and tissues. The personal digital twin may be used to predict human health, behavior, and emotion in advance of developments warranting concerns or requiring attention, and even simulate people's thoughts to realize spiritual immortality in some extreme sense. Our personal digital twins can be transmitted to any place in the world in real time, through the pervasive network of various activities, be it attending a concert, enjoying the beaches and the sunshines of the Maldives, or hugging family members and friends that are oceans apart. This chapter will examine the usage scenarios of personal digital twins, the challenges, and the wide varieties of technologies involved, encompassing personal digital twin information acquisition, transmission, processing, and presentation. In particular, wireless body area networks, W-bands, and multi-source data fusion will be highlighted. Personal digital twins will rely on the joint development of many technologies from multiple disciplines, such as brain-computer communications, molecular communications, synesthesia interconnection, AI, and intelligent interaction. We will present a variety of healthcare applications as a part of a very early stage list of accomplishments in our personal digital twin platform development, as well as the outlook of personal digital twin related developments across the globe. So yeah, your personal digital twin includes your appearance, your external appearance, how you look, includes all your organs on the inside and your tissues, right? And as you said, it can predict human behavior. It can predict human health, behavior, and emotions, also allowing them to simulate your thoughts. So they're in your head, they're in your brain. In order to simulate your thoughts, they got to be reading the thoughts first before you even simulate them. Now we're going to go over here to ResearchGate, and we're going to read Optical Wireless Communication, a candidate for 6G technology. We discuss herein whether an optical wireless communication system can be a candidate for post-5G or 6G cellular communication. Almost once per decade, cellular mobile communication is transformed by a significant evolution, with each generation developing a distinctive concept or technology. Interestingly, similar trends have occurred in optical wireless communication systems based on visible light and light fidelity, Li-Fi. Unfortunately, optical wireless communication is currently relegated to a limited role in any 5G scenario, but the debate whether this is unavoidable has yet to be settled. Whether the optical wireless communication is adopted post-5G or 6G is not the vital issue. Rather, the aim should be that the optical wireless communication coexists with 5G and 6G communication technologies. In working towards this goal, research and development in optical wireless communication will continue to extend its benefits and standardize its systems so that it can be widely deployed in the market. For example, given that a standard already exists for a visible light beacon identifier and Li-Fi, a service using this standard should be developed to satisfy user demand. Toward this end, we propose herein a method for visible light beacon identification that involves using a roller shutter to receive visible light communications with a smartphone camera. In addition, we introduce a rotary LED transmitter for image sensor communication.